Before we dive in, I just want to wish you all a Merry Christmas.
This is an interstellar visitor, and it's telling us more than we expected. New observations of 3I Atlas show an object that isn't fading quietly into the background. It's active, structured, and surprisingly organized. Let's break down what the latest data actually shows. On November 30th, 2025, Hubble was in exactly the right place at exactly the right time. The observation was taken near 3I Atlas's closest approach to Earth. That timing matters. Hubble used its WFC3 camera with the F350LP filter, giving a spatial resolution of about 56 kilometers per pixel. That's sharp enough to probe the inner coma in real detail. And when researchers enhanced those images, they didn't see a smooth, featureless cloud. At first glance, all you see is glare. A dense, bright inner coma, so luminous it overwhelms everything else. That brightness hides the nucleus. It also hides any fine-scale activity close to the source. To the naked eye, this looks smooth, almost featureless. But that's not where the story ends. To see what's really happening, the raw data has to be treated carefully. Researchers apply a 1/r filter to normalize brightness. That reduces the glare from the central core. Then, a Larsen-Sekanina filter is used. It suppresses smooth background light and enhances narrow, directional features. This doesn't add anything to the image. It reveals what's already there. And once that glare is stripped away, the inner coma stops looking smooth. This is what was hiding in the glare. At least 6 faint jets emerging directly from the inner coma. They're narrow, they're straight, and they radiate outward from a common center. These aren't random wisps of dust. They're structured features anchored close to the nucleus. This kind of pattern points to localized active regions on a rotating body. Once the jets are visible, their geometry can be measured. Each jet has a well-defined position angle, spread across the inner coma in paired directions. Those pairings aren't random. They line up symmetrically around a preferred axis. That axis is interpreted as the object's spin axis, projected at roughly 110 degrees. The main tail and the anti-tail fall along predictable directions, separate from the jet system itself. What this tells us is simple. The activity is organized, and it's tied to rotation. Seeing jets in an image isn't enough. You have to test whether they're real. So researchers measure brightness in a full circle around the nucleus. That circular slice is then plotted against angle. If the coma were smooth, the profile would be flat, but it isn't. Instead, you see sharp peaks. Each peak corresponds to a jet. This turns a visual impression into a quantitative fingerprint. So we know 3I Atlas is structured. Now the question is, what it's made of. That's where Gemini comes in. Its data doesn't show shapes. It shows chemistry. 3I Atlas didn't form here. Its trajectory shows it came from outside the solar system, passed through perihelion, and is now heading back into interstellar space. That makes it more than a passing object. It's a sample from another star system. To understand what 3I Atlas is releasing, you need spectroscopy. On November 26th, Gemini North on Mauna Kea took a detailed look after the object passed perihelion. This isn't about shape or structure. It's about light split into its components. And that light carries a chemical signature. Gemini didn't just see chemistry, it saw contrast. In blue light, the coma appears nearly circular, diffuse, uniform. But in red light, the shape changes. The brightness concentrates. A teardrop form emerges, with structure pointing away from the nucleus. That difference isn't random. It depends on what wavelengths are tracing gas and which are tracing dust. Different materials respond differently to sunlight, and Gemini is separating those responses. There's another shift Gemini picked up, and it's in color. Earlier observations, before perihelion, described 3I Atlas as red. Post-perihelion, that changes. Gemini measures a G-R color of about 0.73 with a very small uncertainty. That's significantly bluer than expected. A change like this usually points to evolving activity, fresh material exposed, or gas emissions starting to dominate over older dust.
Gemini doesn't just measure color. It measures molecules.
The spectrograph detects a gaseous coma surrounding the object. Clear emission lines from cyanogen, Cn, from diatomic carbon, C2, and from tricarbon, C3. These are not surface reflections. They're gases being actively released. That confirms ongoing outgassing after perihelion. In other words, 3I Atlas is shedding material into space right now.
Put all the Gemini clues together and a consistent picture starts to form.
Before perihelion, the surface appears weathered and red. As the object passed close to the sun, solar heating changed that balance. Older surface layers were stripped away. Fresh material beneath was exposed. That newly revealed material is bluer, more volatile, and actively releasing gas. The outgassing reshapes the coma, feeds the jets, and alters the object's appearance. This isn't a static relic. It's an object still evolving as it passes through our system.
3I Atlas doesn't answer every question,
but it does something more important. It shows us how much information is still hidden in careful data. Structure where we expected smoothness, chemistry where we expected dust, change driven by solar heating and rotation. This is what an interstellar visitor looks like when you let the evidence speak. And while 3I Atlas continues its journey out of the solar system, there's more happening across the sky right now. Let's move on to today's space updates.
Next, a quiet but rare moment in our own solar system. This image shows Titan, Saturn's largest moon, just after completing a transit across the planet's disk. Events like this only line up about once every 15 years, when Earth, Saturn, and Titan fall into the right geometry. Captured on December 24th from Manorville, New York, by Philip Smith. Even without color data, the timing alone makes this observation special. It's a reminder that rare alignments aren't only interstellar. Sometimes they happen right here, if you're patient enough to catch them. NASA is working to re-establish contact with the MAVEN spacecraft at Mars. The spacecraft was last heard from on December 6th. Since then, recovery commands have been sent and tracking data is being analyzed. Efforts are now limited by Mars solar conjunction, when the Sun blocks direct communication between Earth and Mars. Contact attempts will resume after January 16th, once the conjunction period ends. That's the space update for today. From an interstellar visitor revealing its structure, to rare alignments around Saturn, to ongoing work at Mars, which of today's updates stood out to you the most? Let me know your thoughts in the comments. If you want more calm, evidence-based space updates like this, make sure you're subscribed. I'll see you in the next update.